and we're going to explain about the trigonometric functions of a right triangle. In right triangles, trigonometric functions are defined as follows. Let theta be the acute angle of a right triangle. Since we already knew that the angle opposite to the hypotenuse is 90 degrees, all we've got to do is to find the remaining identities using the mnemonic SOHCAHTOA and KAUSHAT-CHO. SOHCAHTOA stands for sin theta is equal to opposite over hypotenuse. Ka, cosine theta is equal to adjacent over hypotenuse. And last, TOA, tangent theta is equal to opposite over adjacent. KAUSHAT-CHO stands for Kau, cotangent theta is equal to adjacent over opposite. Sha, secant theta is equal to hypotenuse over adjacent. Cho, cosecant theta is equal to hypotenuse over opposite. SOHCAHTOA and KAUSHAT-CHO will help you to remember the formulas easily in solving right triangle trigonometric functions. Let's try an example. This angle of a right triangle is what we call the theta, and the opposite of this theta is what we call the opposite, or what we name as side B. And the adjacent of this theta is what we call the adjacent, or the side A. The hypotenuse, or referred as side C, is the longest side of the right triangle. In order to get the hypotenuse, we have to square the adjacent and square the opposite, then add the two and get the square root of the sum.
We're going to solve a triangle which one of its sides changes. So you're given an angle that's going to be 45 degrees. I think it's going to be 10 meters. So we're going to solve for this side. Suppose I'm the colonel and Mr. Guyver is a captain. And then one of those French guys just shot a missile toward the captain, and so I am the observer. And I have an angle measuring system, and so I've measured it as 45 degrees. So with that, I can compute how far is Captain Guyver from this guy. And it's going to be tangent 45 is equal to opposite over adjacent, so that's going to be the side which we would call computing for this. Since we are computing for this side, we can compute it by tangent 45 is equal to the opposite, which is this side. So we can call x over 10 minutes. So x is equal to the tangent 45 times 10. So it's going to be equal to 10 meters also, because tangent 45 is equal to 1, and then 10, so it's going to be 10 meters. So now, if this side changes, because it's a missile, it's going to change. It's going to go towards the captain. So if this changes, what would happen? So let's try. Suppose it's in this position. I have calculated also at 15 degrees. Can we calculate it? Can we make a function out of this diagram? Well, yes, we can. So it's going to be tangent of theta is going to be x over 10 meters. 10 meters is constant. So 10 times the tangent of theta, or what theta is equal to x. So you can simplify this as x equal to 10 tangent theta. So if we have the 15, so 10 times the tangent of 15 is going to be x, as always. So x is going to be, and since we have this formula, it's going to be 10 times the tangent of 15, so it's going to be x is equal to 2.68 meters. And then, if we solve it, that in impact, what would happen to Captain? It's going to blow up, but can we solve for the angle there? Yes, we could. So the tangent of, what's the angle when we reach here? It's going to be 0 degrees. So that's going to be the tangent of 0 degrees is equal to the opposite over adjacent. So the opposite is still 0 degrees over the adjacent, which is 10 meters. So tangent of 0 is equal to 0. 0 is equal to 0. It's all right. We have solved it, and therefore our function is substantial. Here we go. We can use trigonometric functions to So use triangles for.
Go.
What's the plan, sir? So this is how it's taken. Some of the men are dead. Yeah, none of those cavalry regiments are dead. So I think you need to scour out the enemy, spy out them. They're never gonna take this trench back, though. Good luck, Captain. Oh no, I think the French reinforcements are back! Oh no, Captain!
Hey,
Take position! Fall back, man! Fall back! Fall back! Try